Hello students, I am Dr. Sanjeev Punia. We are discussing 3D transformations in computer graphics. This comes under second unit. In this, we discuss 2D transformations and we saw that what's the difference between geometrical and coordinate transformations. After this, we discuss about the matrix representation, that how we can represent a 2D object in the form of matrix. In matrix representation, we discuss that how we can represent that matrix in a homogeneous coordinate system. Then we discuss about the basic transformations on 2D, that is translations, scaling, rotation, reflection, and sharing. And in the last, we discuss about the composite transformations under the basic transformation scheme. After completing these 2D transformations, we studied window to viewport transformations. And now we are continuing from 3D transformations. In 3D transformations, we discuss that how we can represent a 3D object in three-dimensional. Then we discuss some basic operations as those we discuss in 2D, that is translations, scaling, and rotation. Till here, till these three operations on 3D, that is translation, scaling, and rotation, we completed till last lecture. So from today onwards, we will discuss reflection. So let's start reflection. So reflection is also a kind of rotation. Reflection is also a kind of rotation. We know that this is a mirror, and when this is suppose a mirror, and when we are standing inside of a not inside, when we are standing in front of a mirror, then we see ourselves on the same distance. Suppose this distance is x from the mirror, then it is reflected to us that the image of this object, our object is on the same distance. On the same distance means over here x also, but on the another side of the mirror. In this, we can say that the size of the object, when we are doing reflection, in that case, size of the object remains same, as well as distance from the axis also remains same, but coordinate systems change. Suppose we are discussing in 2D, as we discussed. Suppose this is an object, and when we are reflecting this object with respect to this axis, then the object of this is, then this object is same as it is, and it will reflect us that this object is at same distance away from the axis. When we are seeing this with respect to axis y, and it also happens in the case of rotation, but when the rotation is 180 degree. So this is a special case of rotation in which theta equals to 180 degree. So this is not a different transformation. This is the special case of rotation. So in rotation, we have to use an angle. The value of angle can be anything, but in this case, the value of theta, that the value of rotation is 180 degree. So this represent a special case of rotation. So reflection is a kind of rotation where angle of rotation is 180 degree. The reflected object is always formed on the other side of the mirror. As I told you over here that suppose this is the object, then reflection image will be on another side. So this was when we were trying to understand the thing in 2D dimensions. Suppose we want to discuss this thing in 3D dimensional. Suppose this is axis x, this is axis y, and this is axis z. So now when we have to reflect, suppose this object A, then instead of axis, when we were doing in 2D like this, now it will reflect with respect to a plane. Suppose this is YZ plane. Suppose this is YZ plane, this is XZ plane, and this is XY plane. So now this object will reflect with a plane that is YZ. If we will reflect this in this direction, and if we will reflect it in this direction, then it will be reflected with respect to x and z plane. So in 2D, the reflection was with respect to axis, and here in 3D, the reflection is with respect to this plane, that is xy plane, yz plane, or zx plane. So the size of the reflected object is same as the original size. So we discuss over here that this is a special case of rotation where angle is 180 degree. The image distance is equals to object distance from the plane, and size of the image is also equals to size of the object. Now Suppose this is a 3D plane. This is a 3D plane. This is x-axis. This is y-axis. And this is z-axis. Now, if I have an object over here and the values of this is x old, y old, and z old. And after the reflection of this object, for an example, I am saying that this is a point A, then after the reflection with respect to any plane, the new coordinates are x new. So this will be x new, y new, and z new. So these are, for an example, the coordinates value of reflected object. For an example, I am saying is a dash. So when we have to solve a question in 3D reflection, then these two things will be given to us, and one more thing will be given to us, that we have to reflect with respect to which plane. So till here we discussed that how the reflections is possible, what we have to do in reflection, and what is a reflection. Now we will discuss how we can perform different type of reflections, or how many type of reflections are. So basically reflections are of three types. We can reflect an object with respect to xy plane, with respect to yz plane, or with respect to xz plane, as I told you by making the diagram on the last slide. So suppose this is one plane, this is another plane, this is xz plane, this is x-axis, this is y-axis, and this is z-axis. So from here we can see that this is a yz, this is a yz plane, this is a xz plane, and correspondingly this is a xy plane. Suppose we have any object over here, then the coordinates of these are x old, y old, and z old, and we can reflect this with respect to this plane, that is xz plane, that is xy plane, or with respect to yz plane. So these are the three possibilities in which we can reflect this 3D object. Now we will see that how we can solve the questions based on these three reflections. So when there is a reflection with respect to xy plane, with respect to xy plane, When we are doing this xy plane, then in that case, suppose this is object over here and we are reflecting it with respect to xy, then it will be over here, means only and only the value of x is same, the value of y is same, the value of z is going to be changed from positive to negative. So you can see from here that when we are reflecting the 3D object with respect to xy plane, then value of x new equals to x old, the value of y new equals to y old, only and only value of z old is going to be changed, and value of z new equals to minus z old. So this is the equations over here. If we want to represent these equations in the form of matrix, then we discussed earlier, this column is for x value, this is for y value, and this is for z value. Similarly, this row is for x value, this is for y value, and this value is for the z value. And this row as well as this row we use to make this matrix homogeneous. To make this matrix homogeneous. As in the case of 2D also, we have or we require only x and y. We require only x and y, for an example 0 and 1 and 2 and 3. Only these are the requirements for an object to represent, but there also we are adding a extra column and extra row to make it homogeneous. So here also we are adding this column as well as this row to make it homogeneous. And when we are adding this and putting the value of x, y, z over here also x, y, z 0, then it has no effect when we are performing the operations on this matrix. So when we have to find out, only value of z is going to be changed from here. You can see that when we want to find the value of x new, so this is this row multiplied by this column. So this is only 1 is over here, so 1 is going to be multiplied with x old. So we get x old, that is x new equals to x old, and rest 3 are 0. Same when we are going to find out the value of y, so y new equals to this row multiplied by this column. As all the coordinates x, z except y are 0, so rest of the values will be 0. Only this 1 is going to multiply with this y old. So the value of x new will equals to old value of y coordinate. Now, as we discussed here in the equations, that value of z is going to change, but that is from positive to negative or negative to positive, means sign of the value of z is going to be changed. Then x and y are 0, so when we will multiply x and y, so this x and y old are 0. Only multiplying by the value of z old over here, we are getting minus z old. So z new equals to minus z old. We can keep one thing in mind, that the plane with respect to which we are reflecting the object, the values of those, that is x and new, x new and y new are same, but the value of third coordinate is going to be changed from negative to positive or positive to negative. So this is z new equals to minus z old. Same thing we will see in YZ plane also. So when we have to say that we have to reflect this object with respect to YZ plane, then as we discussed in last slide, then value of Y and Z coordinates will be same. So we can see from here that value of y new is equals to value of y node, as well as value of z new equals to z node. Only the third axis value, that is x, that is not over here. The value of third coordinate is going to change from positive to negative or negative to positive. So you can see over here the value of x is going to be changed only. Y and z values are same. So this was in the case of yz, and when we will discuss this with respect to xz plane, then this xz plane also, the value of x and z are same, only the value of y is going to be changed. And you can see from here that the value of y is going to be changed with either plus or minus. If the value is plus, then it will be replaced by minus, or if the value of y axis is plus, then minus, and if that is minus, then plus, means it will change. Now we will see an example based on 3D reflection. It will be more clear to you after discussing this example. So, so let's start the example. Given a 3D triangle, we have to given a 3D triangle. Suppose this is a triangle that has been given in 3D axis. There are 3 points or 3 coordinates. A is 341, B is 642, and C is 563. There are 3 coordinates A, B, and C where the values of A are 341, B is 642, and the coordinates of C are 563. We have to reflect, this object, this triangle on xy plane, So from here you can conclude that value of x and y will not change because we are reflecting this object with respect to x and y plane. So only the value of z is going to be changed, and that will be negative of the earlier one. Suppose this is z old and this is z new. Only this will be the change that will going to implement when we will solve this question. So we have to find out the new coordinates of the object. So in this we have given two things. First one, we have given the three coordinates of a triangle A, B and C. The coordinate of point A is 341. Coordinates of this is 642 and coordinate of C is 563, and we have to reflect this object, this triangle, with respect to xy plane. So come on the next page, we will discuss over here. So for coordinate 341, that is for object with respect to point A. Z new, let's Z new is the, this is Z new because as I told you, value of these two x and y will not change. So the value of x, you can see from here, earlier it was 3. It was 3 earlier, now also it is 3. Earlier was 4, so it will be 4. Only value of z is going to be changed from 1 to minus 1. 1 to minus 1. So by doing this, we can find out the values of reflected point A dash, and that is 3, 4, minus 1. Same way, we can find out the value of other points, that is B, C. The B is 642. So the value of X and Y, that is 6 and 4, will not change. Only the value of Z coordinate, that is minus 2 instead of 2, is going to be changed. So final values are 6, 4 and minus 2. In point C also, the value of Z is going to change only from plus 3 to minus 3. Rest of the values, x value and y values, are same. So it is 5, 6, that is same, and z is minus 3 instead of 3. So finally, this is the values of reflected point A, B, C with respect to axis x and y. A becomes 3, 4, minus 1, B becomes 6, 4, minus 2, and C becomes 5, 6, and minus 3. So in reflection, we discussed that this is a special case of rotation where the angle of rotation is 180 degree. 180 degree. Size and distance from the axis of image remains same. Means the size of image and object is same, whereas distance of object and image from that axis, from the rotation axis will be same. In 3D, the reflection is based with plane or with respect to plane, and this is a special kind of rotation where rotation angle is 180 degree. Then we discussed that these are, we can perform 3D reflection in three ways. That is when we will reflect the object with respect to xy plane, yz plane, and xz plane. And we discuss over here that when we reflect with xz plane, then value of x and y plane remains same. Only value of z coordinate is going to be changed. In that is same in the case of yz and xz plane also. Then we discuss a question based on this, and I am confident about it that it will be clear to you now. You can do one or two more questions based on 3D reflection. So in the next class, we will discuss about the sharing in three dimensional. Thank you. Thanks for your patience.